I'm Jeremy Filzetti. I work for the Naval Research Lab. If you've been to Lustre before, you're probably familiar with our briefs. We briefed at the last 2 lugs with what we're doing with Lustre over the wide area. So I think back in 2003, 2004, correct me if I'm wrong, Jim, NRL started prototyping a wide area InfiniBand, basically FPGA, that would take InfiniBand from the local data center, extended over the wide area over a SONET link. And so that was initially prototyped. From there, we went on from demoing at supercomputing to actually releasing that to 2 vendors who've made products since then. So we have Obsidian Strategics and Bay Microsystems are the 2 vendors that are producing a product for that. So we've been using that over varying latencies to do InfiniBand over the wide area for now 3 or 4 years. With that said, we have quite a variety of varying latencies. We have one link that's all the way down to 2.5 milliseconds, all the way up to 200 milliseconds in latency. So obviously performance falls apart pretty quickly on standard links. It also falls off even with InfiniBand links, but it actually sustains much better than traditional Ethernet and TCP/IP. So some of our performance data that we've gathered basically have demonstrated that over an OC192, we can basically fill our pipe all the way up to around the 50, 60 milliseconds, and it starts to slowly drop off and degrade up into about 110 milliseconds with so an OC192 is a 10 gigabit link, of which there's an 8 gigabit SDR connection. For the longer distance link, we have 2.5 gigabit link, so an OC48 going the 200 milliseconds. We've been able to fill up that pipe as well. And so what we're doing is using Lustre over the wide area for all of this. So some of the things that we've seen traditionally are that data is heavily application dependent. So if your application reads 4K at a time and waits for a response, you could have poor interaction or writing in the inverse. We've seen a lot of issues similar to the presentation we just seen about extra stripes causing extra latency. What it looks like there is that when you actually write to a stripe, you don't request the lock on it until you actually need it. So as soon as that write goes to that second megabyte, it has to wait for asynchronous, actually 2 round trip times for that. And what we found in our experience there is that, so depending on your data needs, you really have to outweigh that basically using smaller files with smaller stripes, bigger files with bigger stripes to get that bandwidth. So again, I guess I'll go and turn it over to Ken. So just a quick background on that. So I work from the DoD side primarily, and then we have a test bed that Ken works on. So he'll have completely different stuff and results than I will because we actually work in different environments.
My work has a lot been focused on the security aspects of things. Jeremy's got a really good handle on the performance and can talk to you for a long time about that. We found that the most interesting cases for doing wide area is you quickly get outside of your own traditional security boundary. I mean, a lot of people think about the security boundary is the area within their supercomputer. If you want to do wide area, obviously it's hard to extend your security boundary across the internet. So we want to do some types of secure authentication where you can have reasonable assurances the person on the other side of the internet is who they say they are and they're not writing and reading to stuff they shouldn't be allowed to. Our traditional method of doing security, both in our group and outside to the global internet, has been using Kerberos. We did some original work with CFS back in the day about integrating Kerberos into Lustre. That code is there. It still needs a little more love, I think, before it can get a lot of use, but it's available. We've also been doing some work with people at PSC and Indiana about doing wide area stuff with data capacitor and PSC's JWAN work. Indiana University in particular has expressed some reservations about using Kerberos for the wide area. I respect their opinions. I don't necessarily agree with them, but it's a reality, and I think it's a reality that other people have to face. So we've been working with the people at IU to kind of develop an alternative security system that doesn't use Kerberos. It kind of uses a protocol that a lot of people who are familiar with IETF-based protocols for identity based on SHA-256 hashes. Our thinking is you could have your own user ID space. It wouldn't require on any external infrastructure like Kerberos, but we still want to use, at least our environment, we still want to support Kerberos. I guess our thinking is generally you could have a couple, 3 or 4 different security mechanisms. Maybe in the end we have traditional Unix for local area. For outside of your boundary, you could use this, we're calling it CRAM SHA-256. If you don't want to set up or use a Kerberos infrastructure, and if you have a Kerberos infrastructure, you could use it. And that can be used for the authentication portion of over the wide area.
Going to pass the torch here to Chris Jordan from TACC. He's going to talk a bit about the albedo file system.
Thanks, Steve. So my, in addition to working at TACC, I am the area director for data in the NSF's TerraGrid project, which links a number of large open science-focused supercomputing centers around the United States. And the TerraGrid has actually been involved in wide area file system work now for many years. Beginning with some work with GPFS. They've also done work with long-distance fiber channel and PNFS and a number of different experiments and production file systems. And the most recent kind of iteration of this work is something that we're calling albedo, and it's based on Lustre, Lustre 1.8. And has a slightly different model, I guess, than some of the other wide area file systems we've experimented with in the past. The kind of most common pattern for these kinds of things has been to have a large pool of storage, a large single file system at one of the supercomputing centers, and then to mount that as widely as possible over the wide area networks. And within the TerraGrid, we typically have at least 10 gigabit networks available to us. At different times, we've had as much as 40 gigabit networks available. Currently, it's mostly 10 gig. But that kind of does present a little bit of an issue. If you have a single site, you then really only have 10 gigabits of bandwidth shared amongst all of the client sites. And so one of the things that we've done with this current system is we've actually distributed the storage among currently 6 sites. We have a metadata server at PSC, as well as some storage there, and then OSS nodes that are distributed around a number of sites across the country. And that system is now up, and it's kind of been working and been in testing for some time now. We're working now to get it mounted on as many of the HPC resources that are across the TerraGrid as we can, and start seeing what users are going to do with it. We do have the storage pools kind of capability set up so that users can tag directories, set the parameters on directories so that they use only a specific pool of storage at a specific site, or try and use OSS and OSTs across all of the sites. We've also had to deal with the issue of cross-domain authentication. That's kind of one of the biggest problems that you have to deal with anytime you're doing a wide area file system that crosses administrative domains. When we began working on the albedo project, we talked quite a bit about the Kerberos issue and the different mechanisms that were available, and partially because of the same issues that the last speaker identified, the Kerberos stuff maybe not being quite ready yet, although it does seem promising. We decided to stick with the 1.8 and with some kind of MDS-centered identity mapping technology that's been developed at Indiana, mostly for the data capacitor. So the issues that we had to deal with there, we didn't have to mess with any of the Kerberos stuff, but basically what we had to do is come up with ways to accumulate information about what the user identities are at all of the various sites and what the basically what the sets of IP addresses were that mapped to a specific site, so you know which user identity and IP address maps to which UID on the server node. And so because in the TeraGrid we have some central database mechanisms to accumulate user identity information, we were able to extend that a little bit to add the UID as another field that's held in the database. And so we've been able to come up with some automated mechanisms to gather that and to also gather information about client IP addresses, which are necessary if you want to have automated firewall management. That's the other big issue. As you add client and server nodes across the WAN, you need to be able to manage firewall settings such that the hosts can get to it, at least if you want to have any kind of firewalls protecting your hosts, which people generally do. So there's been a lot of work, particularly at PSC and Indiana, to automate these mechanisms of gathering information using TeraGrid central databases and the TeraGrid information services, and then to use that to automate the process of updating all of the various tables and firewall configuration that needs to be done. That's all I'll say right now. I'll pass it on to the next speaker, I guess.
So I'd like to open this up to Q's and A's now. See if you can maybe pass that around. Are there questions, and if so, where?
Wonder if anybody can address any thoughts, not that it's in any plans, on using SE Linux.
I guess I can elaborate a little bit, even though Ken's really the security guy here. At least from my point of view, I mean, SE Linux sort of guarantees the integrity of the kernel. So we're talking about different systems. So there's really a whole different model that we need to follow. I think part of the steps that Ken's done is a good first step, but really it's cooperative of OSSs and MDSs.
In my last major task, we had to deal with was the HPC, the DoD HPC computing environment, and that has a huge problem of users coming from untrusted systems. And it was sort of an arms race. I could go on for hours about that, about attackers versus countermeasures. And I kind of felt like we were always playing catch up. It's like, okay, here comes out a new tool. How do we come out with a counter to that? I don't know if there exists in general a good solution to the untrusted host problem. Now, I think maybe you were concerned about using SC Linux on server systems?
No, actually, with the whole access to the file system and getting Lustre to have SC Linux labels and doing that over the WAN, to also, protect who can access what data.
I'm not.
It's a huge issue. I was just wondering if anybody's thought. I mean,
So,
I'm asking if anybody's thought about it.
We have thought about it. I've always said that NRL should sort of sponsor some sort of security-enhanced Lustre, basically, where we implement some of the security features we'd like to see within Lustre. But the problem is so for every extended attribute you have from your security context, you've got 2 extra round-trip times possibly per file when you stat a file. So now you've already have this penalty where you have to stat the MDS and then you have to stat the OST. So you've got 2 round-trip times. Now you've just bumped it up to 4 possibly for the applications when you start incorporating extra attributes, extended attributes. So there is definitely a penalty over the wide area when it comes to that, and it is quite noticeable. Possibly the bulk stat or readdir plus could help alleviate some of those problems.
Also, I'll show my ignorance on SC Linux. It doesn't really solve, in my mind, how to put crypto in there, which really what you need at some point in the wide area. I mean, it seems like the stuff I've seen for SC Linux, and I could be completely wrong, was really focused on local system access. And as we know, when you do security over the network, it's a whole different ball of wax.
Anyone else? Next.
So did you try lockless I/O to avert the initial lock getting. Did that help?
Could you please speak up again? I don't think we quite heard that.
Did you try to use lockless I/O so that you don't have this initial latency of additional lock getting when you do your I/O of 1 round trip per stripe?
We didn't do it. Did you do anything with lockless I/O? No one here has tried anything with doing lockless I/O. So no, we didn't try it.
Okay. And the other question is, do you think we have this current feature that the locks can actually be acquired in parallel, but it could only be done when you do things like stat, because otherwise it's deadlock prone if we actually request real locks. But we can sort of implement a feature that when you open the file and request and do a stat on a file opened in write mode, it will fetch you all the write locks, at least in parallel. Would such a pre-priming thing would be interesting for you?
I think definitely.
Will you be able to actually force your users to use such a feature, or would this be a feature that actually would be there but nobody would use it and still complain about the extra huge latency?
I mean, hopefully we'd have some sort of syscontrol interface or LCTL interface to be able to turn on that lockless mode on a per client basis. So those that need it could certainly, the heavy write loads could handle it.
I mean, I don't mean that open automatically would fetch the attributes, because I assume not every open needs to do that. But there would be an extra step required of you do open followed by stat to get the benefit. Would that be useful?
So from my perspective, we are running a lot of applications where we don't get the source code. So I think in these cases, we don't have a chance, right?
I see. Okay. Thank you.
Next. Anybody?
So what are some of the issues that you might foresee in having like a Lustre WAN gateway at a traditional HPC center, where you're using this single system, single file system potentially between just a small number of large computational systems?
A lot of the issues, and this is one we ran into with the DoD HPC program, were political, in the fact that people weren't really crazy, although the DoD HPC was a little bit different, that it was their mission to accept users from outside of their facility, so they kind of had to make it work. I think a lot of the issues are getting through a number of the political barriers, more so than it surprised me than the technical ones. From the engineering perspective, the technical ones are relatively straightforward, but overcoming the political barriers in, like, how do you pass your security, your site's security requirements and security audits, those change very dramatically when you say, oh, we're going to be able to have anyone on the internet mount this file system. I mean, that's my goal. What I'd like, don't think there's a reason you shouldn't be able to use Lustre from Starbucks if you have the right crypto, but we're not anywhere near that yet. So, I mean, they did a lot of good work. I think I didn't realize about some sort of scripting the firewall access stuff. So I think it's a lot more political and administrative than technical. Those sort of issues, kind of doing something that you hadn't always done in the past. Another thing that comes to mind is a lot of vendors ship supercomputing systems that aren't really ready to have access from the internet. So opening that up, they're sort of configured in ways that they don't really expect to have to deal with security issues from people coming from the internet. Now, I haven't looked at any of the Lustre appliances myself. I suspect a number of them have issues that we'd have to go through them with a fine-tooth comb before they could pass one of our security audits.
Yeah, I think that the identification of politics as being one of the big issues is really important. There's a bit of a chicken and egg problem here, where from the user perspective, users may want it, but they're not going to use it and speak about wanting to use it until they have access to it. And a lot of the administrators are not going to provide access to it until the users say that they want it. And so getting over that barrier is always a bit of a challenge. And just a little bit more on, the architecture of a lot of these systems does make it difficult, both in terms of having internal networks that may not always interface with TCP/IP in a smooth manner, having to deal with routing between the clusters and the external world, and then also just having very large numbers of nodes inside some of the large systems that then presents a challenge in and of itself. The other thing I would point out is that these types of file systems, I think, are becoming increasingly useful as the kind of typical workflows are beginning to change a little bit, and the importance of data and the importance of larger numbers of resources and distributed resources becomes greater in particularly high performance computing and a lot of scientific research work nowadays. These kinds of resources have a potential that they didn't have so much in the past, and not everybody necessarily realizes that yet, and so there's a bit of a lag there.
I've got a question for Scott, actually. I mean, you were singing the praises of Lustre WAN. What are the pains that you suffered?
Well, I would say, I mean, to address the previous question as well, there's always an issue of networking. I mean, it's sort of a crapshoot when you connect up a client. Sometimes it works really well, and sometimes it doesn't. And there's 10,000 different places to check for where the problem is occurring, and especially when you're working across multiple national networks and trying to really track down bugs from one data center through like a TACC network into another data center. It can be hard to get it right. Luckily, though, once those things have been ironed out, I think our experience has been they stay pretty well in place and continue to work. So, I mean, we've been running our workflows for a couple of years without too much difficulty. But to get those initial connections can be a challenge.
Okay. Any more questions?
Have any of you been able to accommodate small file I/O?
It works.
You can do it, man. Expected.
Yes, it works.
A lot of astrophysics, that's fine, but what happens when you know?
Right. So one of the things that I was wanting to mention as far as kind of going forward, I think some of the more hierarchical kinds of storage arrangements are going to be really important for high performance computing in general, but particularly for these kinds of file systems. Being able to find ways to put higher performance resources closer to the systems and kind of stage the way that data moves around from local systems to remote systems is really, as far as I can see, the only way that you would deal with that issue in a WAN file system kind of environment. And I think it's going to be very important for the kinds of workflows that you just mentioned in general, even if you're not talking about a WAN.
Anything else?
This question is for Scott. You mentioned that you guys are using some shared memory machines. Can you just talk a little bit about how you have those machines or that machine connected to Lustre? What kind of performance you're seeing if it's many cores in one box?
Right. Yeah. So the numbers that I showed in or the systems that I talked about in my talk were the Altix 4700 at Pittsburgh and one at NCSA. And the nice thing about a single system image is that you can get the full 10 gig pipe connected to that image. So we were able to get in production multiple gigabits. I think we topped out around 4.5 gigabits writes from the simulation to the file system. Typically, the distributed memory analysis stuff that we did, all the nodes are connected at a gigabit, and we're pretty much able to saturate those links when we're reading back the data for our analysis. So, I mean, as far as the performance went, it was, I mean, it was very good, and we never really had any complaints about that once the links were in place.
Okay, we got one more if there is one.
What is your experience with administration of distributed file system across sites with different organizations? So if OST fails on remote file system, what can local administrator do about it?
Yeah, so it was a challenge getting started, especially finding all of the right resources at all of the various sites to manage the systems and set them up was a particular challenge. And then if you have staff changing over time, then keeping everyone up to date on what the systems are and why they're there and what needs to be done is a challenge. But that's also a big part of why we've put a lot of emphasis on automated management mechanisms for things that need to be done on a regular basis to kind of keep the configuration up to date as clients change or users change. You know, having those mechanisms as automated as possible so that you don't always have to invoke an administrator at a remote site to get something done is really critical. Just to keeping their workload down as well. But once you've got things set up and going, it's kind of like the network. You have lots of really idiosyncratic issues initially, and then everybody understands what's going on, and it kind of keeps working okay after that.
Yeah, I'm just wondering if anybody's tried using an I/O forwarder, ideally a caching one, as a security proxy. The thing that concerns me about putting security into the fundamental Lustre protocol, the way it's done at the moment with security wrappers around every connection, is that we still have to really implement capabilities so that authorizations done on the MDS can apply to operations done on the OSTs. And the thing that scares me about that is the huge size of capability caches that you might end up having to have all over the place. So I'm just wondering whether we should be rethinking the security architecture and going more for something like a security proxy as your gateway to the WAN. I mean, the low-level networking stuff, we can still do filling the pipes using Alnet across the WAN, but I'm just wondering whether we should really be going to penalizing all of the sort of local file system access with all of the security overhead.
I share your concern, and believe me, I've started to look at how the sausage actually gets made underneath in terms of security. And certainly investing, like you said, the capability stuff is a concern. I was always thinking that, at least for local users, we'd have a couple different tiered level of access where local users wouldn't have to get capability hashes at all. Again, like you said, the capability stuff isn't quite finished yet, so it hasn't been an issue yet. But in terms of security proxy, well, I guess I could see where that would work, though I don't know. We'd have to talk more about how that all would actually be implemented, what you were thinking, how that looked like.
Okay. Thank you, speakers. Thank you, panelists.